right, so in this series, we'll go over some free tools you can use to help automate your data analytics processes. And at the end of this video, you should have enough understanding on how to import data, clean data, transform data, filter data, and even export that data into a CSV. So for this video, we're using R and RStudio. I'll put links in the description for that. They are free resources, and let's get started. Now, what you're going to see is going to be intimidating at first, but trust me, bear with me. It'll make sense as we get through it. So we're going to start by importing the data. We're going to add a new column. We're going to split that data out and then export that data into two separate CSV files based on the value of one of the columns. All right, so to get started, we need to import the data set. And there are a couple ways we can do that, but we're going to start with the easy way, which is importing the data set here. Now we can import Excel files, SPSS, I mean we can import a lot of different things. We'll get into data connections later, but for right now we're just going to import from text and use the reader package. All right, and then we browse for the file, and it's on my desktop right here. Okay, it's going to take a minute to retrieve all the data so we can preview it, because it is over a gig. So to start off, it's going to load the reader package. So reader is an additional package that we're using. It has some additional capabilities on importing the data, which makes life a little bit easier. And then it's going to assign that entire CSV file to a variable, right? And we're going to rename this variable here to df, which is a common naming convention. Right, so all of this data in here, as this sheet, as you're seeing it, will be referenced as df in the R code. Right, we'll get to that in a little bit. So there we go, just changed it. So it's going to load the package. It's going to import the CSV file, and then we're going to view it. So we're going to take a look at it just like this. Right, and it's still trying to preview. There we go. All right, copy that. I'm going to import, and now it is executing. Right, so while this is executing, this portion down here is the console or terminal, and then the portion up here is, so think of the portion up here kind of as a blank text document. You can do all your coding here, and then you can execute it in chunks or the whole thing, and it actually takes that code when you execute it, and it pipes it into the console and runs it from there. So we're going to be keeping most of our code up here. That way we can save it and reuse it in the future. All right, we don't need to look at that. But okay. So the data is loaded. It did pop up the view, which we're going to click here. And we're going to take a look at this. So real quick, the area FIPS is a county code. So the first 2 digits represent the state, and then the next 3 digits represent the county ID. Industry code is part of the NAICS, the North American Industry Classification System, which is kind of a weird categorization system. So like 11 would be agriculture, farming, logging, things like that. 111 would be crop farming specifically, and then 1112 might be melon farming. So the more digits there are, up to 6, the more specific and granular that data gets. So as you can see here, we're mixing 2-digit codes with 4-digit codes and 6-digit codes. I mean, we have a lot here. So it's hard to do analysis when, you know, this all these 221s, 2211, all these actually roll up to the 22 number. All right, so if I was to sum everything, all the 3 digits that started with 22, it would total this 22 number. All right, so those are the things we need to separate out. So the first thing we're going to do is create a new column based off of this area FIPS column. So we're going to call it state, and we're just going to get the first 2 characters of this column, since that's the state. And to do that, we're going to start off with the data frame, the object that we're dealing with, and then we want to use a $sign. That will allow us to access all of the different columns in there. Right, so if we wanted to select a column, let's say area FIPS, if we ran this, it will actually list out the value of area FIPS for everything here. So it will give me over 7 million observations. There we go. So it gave me all of these observations, and we reached the max print, so it cut it off from there. But if I wanted the first object, I could just open a bracket, put 1 in there. If I ran this, it would give me the first object right there. Right, so the one we're looking for. So you can select or reference columns with that $, and you can also create new columns with that $. So we're going to create a new one called state. And this less than dash is a way of assigning a value. So what we're doing is we're saying, all right, df $state is going to have the value of, we're going to use a substring function. So kind of like left or mid in Excel, we're going to use substring, substr, right? And it gives you the arguments right here. Also, side note, if you ever select the function you're trying to use and press F1, this fancy help document comes in. So in the help document, it'll give you the usage, the syntax, so you want to start with the object. So in this case, it's going to be df $arrayfips. And it's going to say, all right, what's the first character? Where do you want it to start? And then where do you want it to stop? And it should usually have examples at the bottom too, right? So substring A, B, C, D, E, F. It's going to start at 2, end on 4, and 2 and 5. It doesn't show the output. That's sad. But we can actually get this and run it. This is where these examples are helpful. So if we ran this, that was not helpful. Okay, here we go. 2 to 4. So it's going to start at 2, B, and end at 4, which is D, right? So it gives me B, C, and D. So what we're going to do here is we're going to say start at 1 and end on 2. And if I do this, it should give me 0, 1 for all of these, and it give me the state for everything. So it's still processing. There we go. It finished. So now if I go here, I now have a column called state, and I have all those values. Okay, and now we're going to create 2 new data frames based on the character length of this industry code field. Right, so we want to separate those out because a 2-digit NAICS code is a lot different than a 3-digit NAICS code. So similar to how we created a new column by just establishing it and then assigning something to it, we're going to create a new data frame. You can name it whatever you want. Bob works, or in this case, we're going to make it a little bit more helpful and call it NAICS2 because we know it's a 2-digit NAICS code. And again, we're going to start off with the data frame that we're working with, or that we want to base this off of, which is DF. And then this is similar to the R1C1 format of Excel, if you've ever dealt with that. So in this case, if you want to start accessing the specific rows or columns of a table, what you would want to do is format it as row, comma, column. So I can select rows 1 through 5. I can select just the ArrayFips or own code. This is a little bit different than the $, because the $sign is only 1, and here I can assign multiple values, right? So what I'll do here, just to demonstrate, I'll do 1 to 5, and then I need to give it a list, right? Because it's expecting just to be fed one variable. So in order to give it that list, you use C parentheses, right? And then you just put it in parentheses. So we're going to do ArrayFips, own code. There we go. It's very helpful. It tells you offer suggestions. Industry code. Okay. So just to show you what this looks like, I'm going to highlight this C and then parentheses. And if I run that, it gives this list here. Don't mind this error. This is just the current environment. It's just not saving all these things that I do. So it gives this list of 3 objects. So those 3 objects are getting fed into this column argument. So now if I run this whole thing, it's going to give me rows 1 through 5 and just those columns. And there we go. ArrayFips, own code, and industry code. And that's the first 5 rows. So if you think about this, these are also filtering conditions. So I don't want to go through and manually pick all the rows. So what I want to say is I want all the rows where the industry code, so df $industry code, where the character length is 5. So I'm going to do this a little bit backwards. So we're going to use a function called nchar, which gives us the number of characters here. So what this function does is it's actually going to iterate through each row of this industry code column, and it's going to say, okay, how many characters is it? Is it equal to 5? Is it equal to 4? Whatever. So this is actually where we set that condition. You know, we need to set that to 2. I had that wrong. So it's only going to take out rows where this evaluates to true, right? And then if we leave columns blank, it's just going to pick all the columns. So it saves us a lot of time, especially when you're working with 40 or 50 or however many rows of data. So if we run this, it'll create a new data frame. There we go, called NAICS2. And there we have it. And so this one has 230,000 rows of data, whereas the original has over 7 million. So we have the second data frame. Now we're going to do NAICS3. And I'm going to be lazy and just copy and paste this. All right, and we run this. And now we have NAICS3. So we already filtered out the 2 data frames that we're looking for, and we added that state column. So since we're basing it off this and we already added that state column, you will find that the state column still exists, right? So it just gets carried over. It just basically makes a copy of it and stores it as a new data frame. So we have those. Now we want to save those as some sort of CSV. So we're going to use a function called write.csv, and we're going to hit F1 just so we can see the arguments here. So you can write table, write CSV, it's all the same arguments. It's going to take an X, which is the object to be written, a matrix or a data frame. All right, so the matrix or data frame that we're looking for is NAICS2, and then file name right here. And that's all we really need out of this. So we're going to call it NAICS2.csv. We need to put that in quotes. And then we're going to do the same thing for the NAICS3. Okay, so when I run this, it's going to output it to my working directory. Now that usually gets set to your documents folder as default. So if I run the function, I'll put it up here, get wd, open close parentheses. All right, so if I run this, it'll tell me, yep, it's going to my documents folder. So you can also set this to output to pretty much anywhere else. You can change your working directory. You can do a lot of different things. So I'm just going to run these. And output 1, it's writing the second. And that's it. So the great thing about having this in a code format is for reproducibility. So now that we have the CSV files exported, I just deleted them. I'm going to go through this process again and just show you how quickly and easily this is. So you can set it up once. You can put any number of conditions or exceptions in all your filtering and transformations. And then you can just come here and run this code. And it'll just start executing. So while this is continuing to export the file, the great thing about R2 over SSIS is there are a lot of packages available for connecting to different data sources. If your company uses MicroStrategy, there are packages out there that allow you to connect to MicroStrategy sources, reports, and pull that directly into R so you can run analytics on it. There are packages for, if your company's in healthcare, the Center for Medicare and Medicaid Services has a package to connect to their data sources. If you're in economics, the Bureau of Labor Statistics has a package to connect to their data sources. You can connect to SQL databases, you can connect to Salesforce, you can connect to just about anything out there. So R is a pretty robust language, and as you can see here, you can really automate your data flows, your cleaning processes. It just takes a little bit of coding and a little bit of time, and then anytime you have to do the same process over, you just come here, you hit run, and it's done. So feel free to put comments and questions in below, and if you have any examples or things problems you want me to work through, just post it in the comments and we'll go from there.